Can you see my screen? Can you go to the previous page? Okay, wait. Is it here, Crystal? Is it here? Zihua, can see my screen or not? I feel like why my screen is black color.
Miss can.
Can ah?
Can. I mean
Okay,
just now got short while cannot, but now can now.
okay, okay. So Crystal, is it this page you want to ask me to come back? Page 8. Oh, okay. Here. Page 8 is the work done. If you don't want to using the formula of work done to do calculation, basically you can also using MGH. Okay, the GPE, you see, GPE is MGH. The MG, teacher, it doesn't give us mass what? Then how should we do? MG is actually the weight what dear? MG is weight. So at here we can using 140 times the height. Okay, the height at here, you see, I lift up the object. The height is 3.2. So you will find out that actually this one you will get the same answer. So as I told you, if they give you work done, you can do calculation by not only using Fs, but you can using energy to do calculation. Okay, Crystal, if done, let me know. Okay, done. So boys and girls, we goes to the power lesson number 22. Okay, power is work done divided by time. Do you still remember how I teach you about define the formula? Okay, define the physical quantity by using formula per unit time. Per unit time. So there is one keyword in physics. Rate of what? Per unit time. RATE actually is per unit time. So when we define the power, what is power? Okay, actually no need to memorize. Okay, we will say rate of work done. Or we say rate of energy transfer. Do you still remember that acceleration, V minus U over T? What is acceleration? How we define? We say rate of change of velocity. Okay, what is velocity? Rate of change of displacement. So you must know that rate is to represent per unit time. So there is a lot of definition. We no need to memorize. Do not kill your brain cell. No need to memorize. We just using the formula, but not all can be using formula to define. Okay, but most of them you can using formula to define. For example, what is density? Mass divided by volume. Okay, some of them cannot. For example, F equals to ma. You don't tell me that force is what product of mass and acceleration. That is wrong. Okay, that's wrong. So this one cannot So you need to figure out which one can be defined by using formula lah. Those can be defined by formula. No need to memorize the definition. Okay. So at here we write down power equals to W divided by T. Okay, write down power equals to W divided by T. And we know that work done is energy. Energy is work done. So at here, we also can write power equals to E over T. Okay, so sometimes students cannot memorize. E equals to PT. We can rearrange, become E equals to PT. In Chinese, if you are Chinese, then I teach you. E equals to PT. E, PT. Okay, this is one of the method how we memorize. Okay, but if you are not Chinese, then you have to know that power is energy divided by time lah. But sometimes my student they will confuse, is the power is energy divided by time or energy times time? Then I will tell them EPT, then that is the way. Okay, so at here SI unit for power SI unit we can call it as watt. Okay, if based on formula, how we know the unit? If let's say you forget watt, it's okay. Energy is in joule. Time is in second. So we can say joule per second. Okay, joule per second. So boys and girls, please remember when we are writing power is in watt, please make sure the time that you use must be in second. Most of the time they will trying to give you not in second, can be in minute or hour. Then you have to know that you have to convert into second, must. Okay, because at the end the power unit we write in watt. This is an SI unit. Okay, then power is a scalar quantity because direct we don't need to consider direction. Okay, magnitude only, no direction. So for the energy is no direction. Of course the power don't have direction. Okay, so until here, if okay, then we are going to look at the past year question. Is it okay? Okay, 1 minute is 60 seconds. 1 hour will be 360 seconds, which is 60 times 60 lah. Okay. Okay, we look at here, past year question. This is 2024. Okay, how much power is needed to push the box 4 meter in 3 seconds? Okay, can you try? Zihua, you know Chinese ah? PT. PT. Okay. Angeline, yes? Okay, any others? Do you able to get the answer? Power is equals to work done divided by time. The work done is force times distance divided by time. Okay, force is 40, distance is 4, divided by time is 3 seconds. This one is very straightforward lah. So it's 53 watt. Answer is 53 watt. Okay, answer is C, 53 watt. Okay, can we proceed to the next page? This one is just very simple questions because they didn't trick you at all. Okay, question number 2. A pump does a 460,000 joule of work to raise the water to fill a tank. It takes 7 minutes to fill the tank. What is the power of the pump? Okay, do your calculation right now. What is the power? Angeline, yes. How about others? Have you tried? Power is work done divided by time. Here, they straightly give you the work. Okay? So take 7 minutes. As I told you, the time must be in second. Okay, must be in second. Zihua no. Zihua check. Crystal yes. Crystal correct. Zihua check. Which part you made mistake? You let me know. So this one 460,000. 7 minutes. 1 minute 60 seconds. So we need to times 60. So at here your answer should be 1095 watt. Okay, so if I take two significant figure or three significant figure, also get the same answer. Because the 5 I have to add in 1. So I will become 1100 watt, which is 1.1 kilowatt. So can you see that you have to familiar with prefix, okay? 字画. Oh, okay. Oh, I thought minutes. Yes, it's minutes, dear. Cannot be in minutes. I mean, cannot be in minutes. Here, I got mentioned, dear. Power in watt. So here, power in watt, dear. Here, power in watt. Watt is SI unit. SI unit. So your time also need to be in SI unit. Must be in second. Okay? Okay, dear. Here, number 3. A boy hold onto a bar and pull himself up until his chin is level with the bar. He raised himself through 40 cm in 0.5 seconds. The weight of the boy is 500 Newton. What is the average power he produced as he raised himself? Okay, do it. Angeline, yes. Okay, we let Zihua and Crystal try. Power is energy divided by time. Okay. So what is the energy we have? Keyword at here. Let me check the answer. 子花 no. 子花 no. Crystal no. Hey, you same answer as 子花. I know. Two of you must be didn't convert to SI unit. Am I right? I told you SI unit. Okay, here keyword raise himself. Raise, so what kinds of energy? GPE. So which is mgh divided by time. So mg is what? Mg is the weight. Mg is weight. W-E-I-G-H-T, weight. So at here, it should be 500 times the height. It go up 40 cm, dear prefix cm. So 40 times 10 power of negative 2 divided by the time is 0.5. So your answer at here should be 400 watt. I believe that you choose D is because you didn't convert the cm to m. So this one must be in m. The time must be in second. Right, Crystal? Answer should be B. Okay, yes. So at here, not only the time, but the distance, we also need to in SI unit. Okay, here 2022 November paper. A boy takes 0.6 seconds to lift a book of mass 0.6 kg from the top of a desk and place it on a shelf. So the top of the desk at here is 0.8. Okay, diagram is already show you lah. So power does the boy develop? What is the power does the boy develop? Okay, dear. Any of you? Oh, here? Okay. So question number 4. 1 minute for you to try. Be careful with the unit. Be careful with whatever lah. But here seems like all SI unit question 4. So how you are going to solve the question? Okay, done. So Crystal, try with question number 4. Angeline, Angeline normally very fast one. What is your answer, Angeline? 0.6 seconds. This is the time. 0.60 kg. This is the mass. Then here, what kinds of energy does the boy develop when it move the what? Lift a book. Okay, lift. Keyword lift. Dear, lift. That's why I told you.
Miss, you muted.
Pardon?
I can't hear you just now.
You can't hear me. So from where? Starting from what part? You can't hear me.
The keyword answer.
Pardon?
Keyword.
Keyword lift. Okay, because we know that power is energy divided by time or work done divided by time. So we need to identify what kinds of energy we have at here. Okay, so at here, can you see that leaf? So leaf is the keyword which is showing us there is a GPE energy. Okay, so GPE is mgh divided by time. So from here, can you continue and then tell me what is your answer? Tell me your answer. Okay, Zihua, Crystal, what do you think? What is your answer for this? Angeline, you try again. This is not the final answer. Another hint. Okay, here, book is here, starting. Okay, starting is here. After that, move to here. Okay, this is my hints. Yes, Angeline, correct. Zihua, correct. Crystal, do you able to solve it? Okay, so you must understand now where is the starting point it going to live. So this is the height that actually you live. Okay, so Crystal, yes, correct. So at here, mg is the weight. So mg is the weight. Oh, m is 0.6, g is 9.8, h is the 1.7 minus 0.8 divided by the time 0.60. So this one, the answer should be 8.82 watt. Okay, this question is testing on you. Do you know that which hash or which part of the hash you have to use? So you need to read the question carefully. Okay, so can we proceed to the page number 3? Can we proceed to the page number 3? Yes, Angeline, okay. Crystal, okay. Okay, dear, here. Two farmers use an electrical power elevator to lift. Okay, so all of these objects are having same mass. Okay, as the sunset approach, they increase the speed. Okay, so all these are their mass is the same, m. Okay, it's the same mass. Okay, increase the speed, need to faster lah, okay? Then after that, how does this affect the work done and the output? Okay, they lift this object and then they increase the speed. What is the effect on the work done and the power? So what do you think? A, B, C, D. Increase the speed, move faster. So what is the effect on the work done and the power? If you don't know, then you guess. Trying to guess. Crystal, no. Crystal, you think about the formula of the work done. And then you think about the formula for the power. I got you guys here. W equals to Fs. Power is energy divided by time. Increase the speed meaning that your time is increase or decrease. You using a longer time or using a shorter time? So at the end, what happened to the work done? What happened to the power? Okay, choose again. Zihua, yes. Then how? How it affected the work done and power? Crystal, correct. Angeline, no. Angeline, here, see. Uh, increase the speed. So you think what happened to the time? You using longer time or shorter time to complete the work? Okay, then at here you think about this work done. Will it affecting the work done? Will it affecting the power? Okay, then Zihua, your answer is Angeline, correct. Yes. Okay, so dear, increase the speed. That means that you're using a shorter time to complete it. So how it affecting the work done? You see, W equals to Fs. It doesn't involve with the time, is it? So if let's say today I give you the homework, I tell you that, oh, okay, please complete the homework 5. So maybe you take 1 hours to complete it. Your friends take like 2 hours to complete it. But for me, both of you complete the work. No matter you using longer time or shorter time, you both of you complete the work, did the work. So two of you doing the same work, you having the same work done. Is that clear? No matter you using 1 hour or 2 hour to complete the homework, for me, I just want to know both of you have complete the work or not. Okay, so if yes, both of you actually complete having the same work done. So work done doesn't affecting by the time. Power, yes, you see, power is energy divided by time. The time at here is shorter, then power will be increased. What does it mean? More powerful. For example, the homework, you using it, people need to using 2 hours to complete it. But for you, 10 minutes I can settle, teacher. Wow, I will say, wow, so powerful. You see, you're using a short time to complete the work, then you are very powerful. So short time, power increase. Answer should be donkey. Is that clear? People complete it with 2 hours, but you complete it within 30 minutes. So you are so powerful. You are high power. Is that clear? Crystal, okay. Angeline, okay? Okay. Zihua, okay. Angeline, okay? Oh, Angeline still here or not? Here. Yes. Okay, dear. Question number 6. Four people of equal weight. Four people with equal weight. Then they're using different way to get to the top of the seawall. So some of them is running, some of them is working like this. Okay, climb the ladder. So which person produced the greatest average power? Think about this. A, B, C, D. Which one actually they are the greatest power person? Zihua correct. Angeline correct. Now Krista. Oh, no problem, Angeline. I thought you lost connection. Okay, dear Krista. Power is actually energy divided by time. Energy is work done. Am I right? It's work done. As I told you that, dear, as I told you that, as long as at the end you having same output, you having same, you are standing here. No matter you are using the sleep way or you actually work and then you go up by this way, doesn't matter. At the end, four of you is doing the same work. You having the same work done. Okay, the force time distance, or we say mgh, energy is mgh, same weight is same mg lor. Okay, then the h is here, the height, so same height. So for four of them, actually no matter using what method to go up, as long as four of them is going up at the same point, same height, they will have the same work. Okay, same work done, same work done. But now, how I know the power? I want the greatest power. That means that it will be only affecting by the time right now. Okay, so the time is shorter times. We choose this C as our most powerful person. So like what I told you, how you go up. So if you are complete, people using 16 second only can go up. You using 5 second. We will say you are so powerful because you have the greatest average power. Okay, so can we proceed to the page number 4? Let's go. 子花 say, let's go. Okay, Crystal, let's go. Okay, a student use an electric motor to leave. Again, leave. Keyword leave. So at here we understand energy is GPE. Okay, then after that the motor exert a force 25 Newton on the load. Okay, it leave the load a vertical distance of 2.0 meter. Calculate the work done by the motor on the load. Okay, so what is your work done? Okay, Angeline, yes. Okay, work done is equals to force times distance. The force applied by the motor is 25. The distance is 2.0, so it's 50 joule. 50 joule, okay, 50 joule. If you want to using MGH to do calculation, you will also get the same answer lah, okay? Yes, Crystal, 50 joule. So next, state the useful energy output of the electric motor when it leaves the load 2.0 meter. So what is the useful energy output? Zihua, yes. For A1, yes. State the useful joule. How many joule? Crystal, how many joule? Yes, 50 joule also, dear. 50 joule. Just now it's 50 joule. Now it's also 50 joule. Why? They might asking you why. It's because the work done is the energy transfer. So the work done by the motor is the energy gained by the object. Okay, energy output, useful energy output. Okay, next, the useful energy output of the motor is less. Okay, so in real life, the useful energy is less than the energy input to the motor. Okay, motor provide 50 joule, but at the end, the output is less than 50 joule. So can you explain why the useful energy output is less than the energy input? Input is by the motor, okay? Then the output, for example, if 50 joule, if you really provide 50 joule, and the object also getting 50 joule, then it can move 2 meter. But at the end, we found out that it cannot go to 2.0 meter because it doesn't really get 50 joule. Okay, the output that it get is not really 50 joule. It might be only like 45 joule. Okay, energy converted to the thermal. Yes. So at here there are 2 marks, 2 marks. So we need to not only saying that converted to thermal, but we need to add more point because some of the energy released to the surrounding due to air resistance. Air resistance, yes, yes, can. But here also 1 mark. Okay, need 2 mark, 2 point. Okay, here if you say dissipated to the surrounding through the thermal energy is 1 mark. Due to what? Because of what? Why got energy dissipated? So 2 marks is one is you mentioning about how it where is the energy lost to? It lost to the surrounding to the energy, thermal energy. Then why? Why is losing? Is because there is a air resistance because of the friction. Friction. Because this is a motor. So inside here it might have some friction. Okay, touching the spring with the motor have some friction. Okay. So Angeline at here. So if you only mentioning convert to the thermal store, so that is only 1 mark. Okay, some input energy is transfer as thermal energy to surrounding due to, or we can say that to overcome frictional force. Frictional force can be including the resistance force, air resistance. Thermal energy. Okay, can you count for the B? Student use the motor to lift a different load. So the motor does 80 joule of work when it lifts this load. It takes 5 seconds to lift. Oh, easy. Yes, correct, Angeline. Zihua, do you able to get the answer? Easy what? Power is equals to work done divided by time. So at here is 80 joule divided by 5, so it's 16 watt. For this question, the main thing that I want to emphasize at here is I want to tell you that, okay, the work done actually equals to your energy, okay, energy transfer. So work done is equals to energy transfer. So when they're asking you to calculate work done, asking you what is the energy, actually they will be the same. Then one more thing I want to emphasize at here is because this is a very common question asking you, hey, why it doesn't getting the 50 joule, okay? That perfect case is I provide 50 and you receive 50 joule. But that is not in our real life because real life we got friction, we got air resistance and so on, okay? So some of the energy will lost. So at the end, you see, if 50 joule, it can lift 2.0 meter. But in real life, it cannot lift to 2.0. It might be only 1.8, 1.5 meter. Okay? Same idea. If they're asking you, hey, why? In practice, we found out that the distance that it lift is less than 2.0 meter. Actually, answer is the same. Okay? They're just changing the way how they ask only. But the idea is still the same. Until here, is that clear? Can we go to the page number 5? Angeline, okay? Zihua, okay? Crystal, okay? Okay, Zihua, okay? Crystal, okay? Crystal, no response. Okay, Crystal, okay. Like there, we go to the page number 5. A man is delivering a cardboard to a house. The man rolls the cardboard at a steady speed from the lorry to the house. The friction force in the wheel is 40 Newton. Okay, can you see that? The man is pushing in this way. Pushing in this way. This is the force. So friction force. Where is the direction of friction force? Please must be very understand is all oppose your motion. So this one oppose your motion is 40 Newton. Always oppose the motion. Okay? Then state the force with which the man has to push. The man has to push how many Newton in order to let the cardboard to moving at a steady speed from the lorry to the house? What do you think? Angeline, correct, but can you explain to me why? Angeline can explain to me why your answer is this? 直花荣, how many force? Crystal, what is your idea? 直花 correct, but can you explain to me why? Angeline, yes, correct. That is the answer that I want. Crystal, correct. Do you know why it's 40 Newton? Here there is one keyword there. Steady speed. Please highlight steady speed. Steady speed is constant speed. Is balanced force or unbalanced force, dear? Balanced force or unbalanced force? For this, Zihua, you need to overcome the friction. Yes, but here keyword steady speed. That means that constant speed. This one is balanced force. Force is imbalanced force. So when balanced force, what happened to your net force? Net force should be 0. Net force is 0. What does it mean? Balance what? Left and right to be the same. So at here, your force and the frictional force must be the same. That's why the force is 40 Newton. Okay? Then the cardboard weight 700. So weight is pointing downward. Okay, 720 Newton. 720 Newton. Okay, state the smallest force needed to lift the cardboard. You want to lift it up. So what is the smallest force you need to apply? Angeline, correct. 720 Newton. Object pointing downward is 720 Newton. So you want to lift it up, at least you need to apply 720 Newton. Okay? So Crystal, yes, correct. Okay, dear, can you count for me how much work is done? How much work is needed to lift the cardboard onto the step? Angeline, no. Wait. Yes, 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 yes. Okay, yes, correct, Angeline. Zihua, do you able to follow us? Yes. Okay, Crystal, yes. W equals to Fs. The force that you need to lift is actually 720 Newton. The distance, lift, you see, dear, lift. I want to lift it up. So my distance must be in the same direction. So my distance actually is it move up. Okay, onto the cardboard edge here. So this is your distance 0.20 meter. Okay, the step edge here is 0.20 meter. So this distance is 0.2. So your answer 144 joule, or you can say 140 joule. So dear at here, I want to emphasize is the direction. You see, direction must be the same. The step is 0.20 high. So this is the distance that we move it up, lift it up. Okay, so 144 joule. Okay, we goes to D. The man has to ask his assistant to help him to lift the cardboard onto the step. Together, they lift it onto the step in 1.2 seconds. The man works equally hard. Can you calculate the power developed by each man? Each man they should apply how many power? Yes, Angeline, correct. Good. Let Crystal and Zihua try. Licious, are you trying? Licious? Zihua, faster. I'm waiting for your answer. Yes, Licious. Okay. Power is equals to the energy or work done, or we say work done divided by time. So my time is 1.2. My work done is 144. Am I right? Am I right? What do you think, Zihua? Let me check your answer, Zihua. Zihua wrong. Crystal, Crystal? 144 joule. In order to lift it up, we need 144 joule. But D question, dear. D question, how many? We got two men. Two men work together. That means that the work done for one person can become half. Supposedly you need to apply 144 joule. But because there is another man helping you together, so actually 144 joule, we should divide it by 2. Because two men works together. Two men's work together, okay? Two men's works equally hard. So the work done for one man is actually 144 divided by 2. Total work we need to apply is 144. But because now got two person do it together, so divided by 2. So at here, your answer should be 60 watt. 60 watt. So this is the key point. They want you to think. When two men work together, they work equally hard. So for example, homework, I give you homework 10 question. Two person do it together. So one person only do 5 question only what? Right? Supposedly you got 10 question, but at the end, each of you doing 5 question only. So at here it's the same thing. 144 joule is total. Okay, it's total. Then two men works together, then divided by 2. Zihua, yes, it should be watt, not second, not joule. It should be watt. Okay, until here, is it okay? Can we go to the next question? Crystal, okay? Okay, let's go for the next question. Figure 2.1 shows a conveyor belt transporting a package to a raised platform. The belt is driven by a motor. The mass of the package is 36 kg. Calculate the increase in GPE of the package when it rises through a vertical height. Vertical, this is called vertical, dear. Vertical, this is called vertical height is 2.4 meter. Okay, can you do calculation? Okay, Angeline. Yes, correct. So energy GPE is mgh. 36 kg times 9.8 times the height 2.4. Okay, dear, this is the weight. This is the weight, or we say mg here. Can you see that this direction and the vertical height same direction? Okay, must be same direction for the work done or energy. Okay, so at here, your answer should be 847 joule. 847 joule, or you can write 850 joule. Okay, we goes to B. Can you try with the B? Question B. Calculate the power needed. Angeline, yes, correct. Zihua leh? Crystal? 847 divided by the time, 4.4 seconds. So it should be 100. Ooh, Zihua, why so big? 193 watt. Zihua, what's wrong? Which part you are make mistake? Okay, answer should be 193 watt. Crystal able to follow, Crystal? Yes. Then we proceed to the question C. Zihua, okay or not? Zihua, do you able to identify? Oh, yeah, you. Okay. Like there. C. Assume that the power available to raise the package is constant. A package of mass greater than 36 kg is raised through the same height. Suggest and explain the effect of this increase in mass on the operation of the belt. Okay, if let's say I increase the mass, now greater than 36 kg, power still constant. How it affect the operation? Okay, how it affect? What affect? Yes, what is the effect, and explain why. The operation moving, okay, from the bottom lift until goes to the platform. So if let's say my package right now become heavier, okay, but then the power of the motor still the same, so what is the effect on my operation? So any of you got idea? Angeline, any idea? Not sure, but you can try to give me your idea. I give you some hints. Power. Think about power formula. So it will affecting what? Power is constant. Then how about your energy? How about your time? I give you guys hints. Power is constant. Power is equals to E over T. So at here, power is equals to energy divided by time. Power is constant. Angeline, yes. But the question 3 mark. Yes, 3 mark. Okay, how? So dear, you have to explain what is the effect. The effect is it take longer time. But why? We have to explain why. Okay, so at here, what is the effect on the operations? Answer at here is it will take a longer time. Okay, the time taken at here will be longer. So time taken is longer. Why longer? We have to explain or suggest and explain. Suggest and explain. So power is energy divided by time. This is one of the point because you understand their relationship. Okay. Then power is constant. Power is constant. Then we talk about the energy. So at here, what happened to your energy? Energy is it changes, increase, decrease, or unchanged? What do you think, Angeline? Power is constant because they told us power is constant. Then how about the energy? Will the energy change or not? Got any idea? Mass greater mass. What kinds of energy at here? The energy is the GPE, am I right? GPE. Will the GPE change or not, dear? Yes, GPE, GPE will be more, okay? Will be greater. Greater GPE. Greater GPE. Why? It's because the energy, GPE energy formula is mgh. So if you are using a greater mass, greater mass, that means that this part m is increased, higher. So your energy also higher. Okay? Yes, we can use the formula to explain. Okay, so at here, you see, power is equals to energy divided by time. Let's say I told you this one is one. I simply put some value lah, okay, to let you see the relationship. Let's say this one is 10 watt. Let's say only, energy at here is, let's say 10 joule. This one is 1 second. Let's say, okay, now I will having a larger mass. So at here, I still need to have 10 watt, okay, because power is constant. What happened to my energy? Because my mass increased. So right now, my energy also increase, mg. Okay, also increase 20. So can you tell me what is my time should be applying, should be taken at here? 20 divided by what? We will get 10 divided by 2. Am I right? So can you see that the time actually is increased? Can you see the relationship? The energy is more, but the power still constant. That means that you will take a longer time. Is that clear, dear? So you will get a greater GPE. This one is 1 mark. Okay. So you understand power is energy divided by time. Okay. So the energy and time actually they are directly proportional. That means that energy higher, then time must be higher. So that you will get back the power constant. So at here, the point is what is the effect? Time taken for the motor will time taken is longer lah, to move the object up. It take longer time. So my example at here, I simply put some value here. Is that clear for this part? Can you understand why mgh more? Why it take longer time? Is it okay, Angeline, Crystal, and Zihua? Angeline, okay. Crystal, Zihua? Zihua, okay. Crystal? Okay, good job. Okay, there we go to next page. Efficiency. We want to find efficiency. Okay, efficiency is the energy useful output divided by input. Here, highlight useful, must be useful. Sometimes the question they give you is in wasted. Okay, this one useful, how we find? We can also using the input minus the wasted one. Okay, then that is the useful output. Okay, sometimes they didn't give you directly give you the useful output, they give you the wasted. Okay, then how you find the useful output? Minus total input minus the wasted one, that is the useful. Okay, it can be using energy or power, is the same thing, because power is energy divided by time, am I right? So at here, if you're using power, then it will be energy divided by time divided by energy divided by time. This is output energy, this is input energy. At the end, time and time cancel out. It's still the same. So no matter you're using energy or power, as long as if you using energy, then the upper part should be energy output divided by energy input, energy divided by energy, power divided by power. Okay, so at here, can you do calculation for the filament bulb and the fluorescent lamp? What is their efficiency? Can you do calculation right now? You have to ask yourself, what is the useful output energy that you want? Okay, so 100 joule is starting, then we got 10 joule for the light, 90 joule for the heat. Okay, so you will find out that output energy is 100 joule is actually equals to the input energy. That's why conservations of energy is actually obey. Okay, conservations of energy is obey. So I want you to do calculation for the efficiency right now. And then as a smart consumer, can you tell me which bulb actually, which filament bulb or fluorescent lamp is more efficient? Fluorescent is more efficient. Yes. Have you did calculations here? Crystal, let me have a look. Crystal. Fluorescent lamp, Zihua. Light bulb one is given to you by the is okay, lah, Zihua. Okay, dear, here N. Okay, this is not N, dear. Efficiency symbol is something like N, but we got tail one. Okay, we got the tail. So this one we got the tail, is actually efficiency. So this one should be, ask yourself, what is the useful one? This one, light. The bulb, we want the light. So it's 10 divided by total input is 100 joule times 100%. So our answer should be 10%. Okay, here efficiency is light is 80 divided by 100, okay, times 100%. So at here is 80%. As a smart user, we want this, okay, for Rienson's lamp. Okay, dear, is it okay? Okay, they cannot providing you input, then they cannot provide you the input is 100 joule. How I know input is 100 joule? You using the output, add it up together. The useful output and the wasted output add it up together, because conservations of energy, input and output must be the same. Even they didn't provide you input, but you also need to know the output added up together actually is the same as input. Is that clear there? Okay, Crystal, okay. So we goes to the first question, past year question. Okay, a lamp has a power input. So this one underline, write it down, power input. It wastes 1.0 watt of the power hitting the surrounding. What is the efficiency of the lamp? Okay, dear, do your calculation. Power output. Angeline's, yes, correct, very good. Sihua and Crystal. Zihua, yes, correct. Okay, dear, useful output. You see this one say west. Okay, western. So this one, 1 watt is the western. How many watt is useful? Is actually 5 minus 1. That is useful. So at the end, your answer should be 80% C. Is that clear? Crystal able to follow? Crystal, okay. Then we go to question number 2. Solar panel is used to recharge a battery. Solar panel produce. Dear, I highlight this. In the IG, there is no highlight like this. Produce. I want to tell you produce means that output. Okay, this is the output. Produce. This is output. The panel is 20% efficiency. Can you calculate the input power? Zihua, yes. Oh, you faster than Angeline. Angeline might be also already goes to the question number 3. Power input times 100%. So this one is 20%. Angeline, yes. Krista? Okay. So here, this question, I want to emphasize, produce, meaning that this is output. Okay, this is output. So if you do it correctly, your answer should be 4.0 watt. Answer is B. Is that clear? Crystal able to follow? Okay, you guys go to question number 3. How to calculate? Okay, dear, like this. You using 20% divided by 100%. You move the 100% to the left. Okay, like this. You move this 100% to the left. Because this is times. So you go there, become divide. Then equals to 0.80 divided by P input. So here you will get 0.2 equals to 0.80 divided by power input. So your power input, you cross multiply. Okay, this one you move here, goes to your left. So it becomes times. So it's 0.2 P input equals to 0.8. So P input equals to 0.8 divided by 0.2. So you will get 4.0 watt, like this. Okay, Zihua correct. Angeline, yes. Okay, 2 of you rest for a show. We let Crystal complete this question. Okay, done. Crystal. Then Crystal, you try with question number 3. Power input, P input is 400 watt. Efficiency is 85%. So N is equals to P useful output divided by input times 100%. Okay, so this one is 85% equals to the power useful output. We don't know. Input I know is 400 times 100%. So calculate useful output. But this is not our answer. It's because the question asks you how much power is wasted. So what you calculate right now from this efficiency formula is you getting useful one. Now they ask you how much is wasted. Yes, Crystal, correct. So at here, your answer for the useful output is 340. So the wasted one should be using the total 400 minus 340. Your answer should be 60 watt. Answer is A. Okay, can we go to the page number 9? Crystal, okay? So okay? Okay, let's go. A machine has an input power 200 watt. Okay, write down P input. And a useful output energy is 1 kilojoule in 6 minutes. What is the efficiency of the machine? Dear, do you still remember just now I told you? When you're using the efficiency, if the bottom part is energy, then upper part must be energy. If the bottom part is in power, then my upper part must be in power. You cannot upper part is energy divided by the power, cannot Okay, so at here times 100%. I know the input is I know the input at here is 200 watt, teacher, but I don't know the input output power for the for this case. I don't know the useful output power. Can you tell me how to solve? Do you able to solve it? Angeline, no? You can try again. Zihua, no? Zihua, no? Dear, power useful output power is actually energy divided by time. Am I right? The energy at here, output energy is what? 1000 kilo. Don't forget about the kilo is K is here is 1000 divided by 6 minutes. Convert it into seconds. So it's 6 times 60. So at here you will get the answer of 1000 divided by 0. I think I will get 2.8 watt, something like that. Am I right? So at here is 2.8 watt times 100%. Yes, answer is C, correct. Zihua, don't spam me the message, okay? So here is 1.4%. Okay, dear here, what I want to emphasize at here is this part. This part. Output energy in 6 minutes. From here, we can calculate the power, output power. Output power. Okay? You must make sure power divided by power, energy divided by energy. Okay? So, if okay, then we proceed to the question number 5. Okay, we goes to question number 5 here. In a small hydroelectric power scheme, 800 of water, so this is the mass of water, drop through a vertical height of, so this one is the hash, it drop. Keyword drop, that means that initially what is the energy it has? Energy is GPE, okay? GPE drops. How can you drop? Must have certain height, then you only can drop what? Okay? Electrical output is, so this is output. Output is 10.6 kilowatt. What is the efficiency? There you must very understand about the whole process. So what is this? This is a hydroelectric power station. Am I right? So it's starting got the dam, water dam at here, something like this. Okay, it let the where how to draw? Let me think. Mm, yeah, water store. Okay, water store at here. So there is a pipe to let the water flowing down. Still remember, we turn the turbine, then we turn the generator, then we generate electricity. Okay, electricity. So at here, can you see that electricity is our output? This is our output. Okay, dear, this is our output. What is the input energy, input power? Because I need to calculate power, what? Right? Power. I need to calculate power. I know that efficiency is useful output divided by input times 100%. Why I know I need to using power, not energy? Because here they give you output in kilowatt. From the watt, I know this is power, dear. From the watt, I know this is power. So I know output is power. Input must be also in power. Okay, where is your input, dear? Input is here. Do you still remember what is the energy stored by the water? Okay, energy stored by the water, do you know? Angeline, no. Answer not A. What is the energy stored by the water behind the reservoir? It got certain height, what dear? This one, it got certain height at here, H. What is the energy stored by water? Energy is GPE. Hey dear, when we learn about energy resources, we talk about this. Starting water have GPE, then it will convert it to kinetic energy, turn the turbine, turn generator, then we generate electricity. So this one, the power output is 10.6 kilowatt. Then the input energy, it should be mgh. Okay, but I want the power. Power is mgh divided by time. Okay, so Angeline, now you already get the input power. Can you find the efficiency? Okay, continue and make the efficiency. So this one is 800 times the 9.8 times the height. Height is 2.2. Okay, dear, I don't have the time. You have. Dear, you have the time. Where is the time? Every second. Every second. So this one is 1 second. So divided by 1. Your answer at here should be 17248 watt. So at here, useful input is 17248. Output they tell you is 10.6 times 10 power of 3 times 100%. So your answer should be 60%. 9.8, wait, let me count. 1728. Yes, correct here. Okay, why answer here should be 61%. Okay, but why we choose answer C is because this is the old syllabus. This is 2022. We using 9.8. We using 9.8 is because after 2022, which means that starting from 2023, we are using new syllabus. Our G will be substitute with 9.8. Before 2023, we were using G as 10. G as 10. So if you're using G as 10, then at the end you will get 60%. You get what I mean? Okay, if you're using G as 10, so your answer will get exactly 60%. But because we are new syllabus, we were using 9.8. That's why after we do calculation, we get 61%. Okay? So 直花系. So here, this question I want to emphasize is you need to have a picture, dear. You need to have a picture. The picture is how the process is running. So the water flow, water drop, flow, turn turbine, turn generator, we get the electricity. So electricity is the output. They might be then tell you that output. They said that electricity is 10.6 kilowatt. Then at here you will think, oh, then this one 10.6 is input or output. Okay, this question is kind is because they tell you this is output. They can erase this output, erase it. Electricity is 10.6 kilowatt. Then how I know this is output? You need to have a clear picture on the whole process. Water storing behind the reservoir, water flow, turn turbine, turn generator, we get electricity. So electricity is output. Then what is my input? Water stored behind the reservoir. That is my input. What is the energy? mgh. But because output giving in power, so now my input must be in also power. Then not only with the number, we can know the information. You see, every second in words, they tell you every second. This is the time, 1 second. Okay, for this question, is that clear? Question number 5, is that clear?